Hello everyone, this is our course assignment of Mechanism Sessional ME29002. We have worked on the Viper mechanism. Meet our team: Tanish Goel 21ME10115, Annanya Agrawal 21MF10005, and myself Khushi Agrawal 21ME30039. This is the problem statement: synthesize and make a simulator for the windscreen wiper mechanism shown in tutorial sheet 2, question 6, with no quick return effect. In the simulation, mark the area wiped. Add any new ideas you might have. So, let's see the question 6 of tutorial sheet 2. For the wiper mechanism shown, determine graphically and hatch the area wiped. Take the following dimensions. Now, Ananya will take over and walk you through the calculations of the mechanism.
Now, coming on to the calculation part, this is the schematic diagram for our mechanism. Here is the L1, L2, L3 and L4 with the angle alpha, beta and gamma respectively. Now coming to the displacement analysis, we got a relation x equal to y cos beta plus z sin beta. After a few more calculations, we got a relation of the beta with the x, y and z and the relation of the gamma with the beta. Now coming to the velocity analysis, in the velocity analysis, we had used the previously derived equation in the displacement analysis, that is x equal to y cos beta plus z sin beta. After differentiating it with respect to time, we got a relation of beta dot equal to L1 by L3 multiplied by 30 sin alpha plus 10 cos alpha minus 2L3 sin alpha plus beta divided by 30 sin beta minus 10 cos beta plus 2L1 sin alpha plus beta multiplied by alpha dot. This is the velocity relation. Now coming to the acceleration analysis, we had used the equation beta dot equal to j multiplied by alpha dot. Here j is the Jacobian. So after differentiating it with respect to time, we got a relation beta dot equal to m plus n multiplied by j whole multiplied by alpha dot plus j multiplied by alpha dot. This is the acceleration relation. Now, Tanish will take over and explain the stimulation part of the mechanism.
So now that you have seen the calculations part, let's move on to the actual simulation part of the project. So moving on to the first one. So this is the normal wiper linkage that was created in the software known as linkage software, and it allows us to perform several simulations on 2D linkages. So this is a wiper mechanism based out of the question given, and it has the same exact parameters and the lengths given. So when we run it, you can see the motion being displayed here, and it also shows you the area covered over here. We can also adjust it on our basis and basically make it sway in the direction we want and the angle and the area that we want to cover. You can see that these parts are fixed as mentioned in the question. This is also fixed, and this is revolving in a constant circle of radius 30 mm, and you can see the path plot by this connector over here and the path plot by these connectors over here. So now there's an option in the linkage to convert this file into CSV format, that is export motion paths. So as we exported it, this is the values that we got. Now using these values, we can basically plot whatever that we want, and some of the plots that I'm going to show you are here. So this is the plot of connector C that is shown here. This is the plot of connector D, and this is of the speed of connector D. This is the movement of x axis of connector C, and this is the movement of x values of connector F. So this is all the data that is over here, and based on this data we can plot any values that we would like, and then we can basically draw conclusions based on the results. So now that you have seen the simple motion mechanism of the Viper, uh, let me move on to the innovations that we did in the motion Viper mechanism. So this is the advancements that we try to do in the Viper mechanism. So instead of just normal linkages over here, we added actuators over here. So instead of just moving out in a straight line or in a defined path, it also revolves around this link with a constant speed, as you can see with the values I have mentioned over here, with the CPM 4 and a throw of 4. So as we run it, you can see the different area that it is plotting, and it helps, and you can see that it is covering more area than it is supposed to cover, here enhancing the efficiency of our Viper. These paths remain same. This also remains same. These remain fixed, but as you add actuators over there, the Viper just tends to cover more area and hence provide more efficiency to the driver. And this is at the previous link, and you can see that it covers less area, and as compared to this one covers more area. So this is the modification when we did, and when we try to use the paths covered in this, we find out this file. This is the modified version of the Excel sheet of the new path, and when we go on to plot it, um, this is the paths we get. And as you can see, the paths over here are in the connector f of x. The fx connector is the top connector uh, present over here. You can see the motion changes. The connector f of x here reaches different peak values, and here it reaches different peak values. As you can see that in this one, it covers more area and hence reaches different extreme values. And that was the modification we did in our project. um, Thank you for your time, and I hope you really like